A razor blade cannot slip between the stones of the Great Pyramid. How did ancient builders create such impossible precision without any modern tools? This video reveals the lost construction principles that let early civilizations master stone geometry. By the end, you will see these ancient monuments not as mysterious ruins, but as the products of a sophisticated and forgotten science. We will investigate how they moved 800-ton blocks and shaped granite with simple stones. What does it truly mean for a civilization to leave a mark that lasts for millennia? High in the Andes, the zigzagging walls of Sacsayhuaman stand as a silent, monumental puzzle. These stones, some weighing more than 100 tons, are not simply stacked. They are intricately carved, their edges flowing into one another in a complex, jigsaw-like pattern that has defied centuries of earthquakes. The true enigma lies not just in their size, but in their impossible precision. These builders worked without iron, without the wheel, and without any written plans we have ever found. Yet they achieved fits between stones so tight that a single sheet of paper cannot be inserted into the seams. This is a level of accuracy we measure in millimeters, a standard that rivals modern machining. How could a civilization, by our traditional understanding so primitive, accomplish such a feat? Renowned archaeologist Jean-Pierre Protzen dedicated years to studying the stonework at sites like Ollantaytambo. After meticulously analyzing the cuts and placements, he concluded that the methods used are not fully understood, and more strikingly, they have not been successfully replicated with the same perfection today. This acknowledgement from a leading expert frames our central question: what sophisticated, perhaps entirely different, understanding of geometry, material science, and physics did these cultures possess? They were not just piling rocks, they were applying a deep, systematic knowledge, a lost science that allowed them to see stone not as an obstacle, but as a malleable medium. To grasp the full scope of their achievement is to realize we are not looking at crude ruins, but at the physical evidence of a forgotten intelligence. The search for their principles begins with appreciating the sheer scale of the mystery they left behind. This deep, intuitive connection to stone was the craftsman's first tool. Before a single cut was made, the builder was already listening, learning the language of the rock itself. The sound a hammer made when it struck a surface could reveal hidden fractures or dents, perfect internal structure. This was not guesswork. It was a refined science of observation, built over lifetimes and passed through generations. They learned to identify limestone that would actually harden and strengthen after it was quarried, gaining resilience from the very air around it. They sought out specific types of andesite that could be polished to a brilliant, almost metallic sheen, chosen not just for beauty but for its resistance to the elements. Every choice was strategic. A stone with a fine, consistent grain was selected for the intricate, interlocking joints of a fortress wall because it would wear evenly and resist cracking under shifting weights. A more massive, coarse-grained granite might be chosen for a foundational slab, prized for its incredible compressive strength. This profound material knowledge was the essential bedrock for everything that followed. You cannot create a perfect geometric form if the material itself is flawed or unpredictable. By understanding the inherent personality of each rock type, its strengths and its hidden weaknesses, these builders could plan for millennia. They were not fighting their materials, they were collaborating with them. This leads to the next, even more baffling question. Once they had chosen the perfect stone, how did they shape it with such impossible accuracy using nothing more than other stones? That profound understanding of stone was only the beginning. The true magic happened when that raw material met a master plan. Before a single foundation stone was laid, these architects were working with a hidden blueprint, a system of geometry and proportion that connected their creations to the cosmos itself. Envision a master builder not with a digital tablet, but with a simple, knotted cord, stretching it across the ground to inscribe a perfect square or a circle under the open sky. This was the starting point. From the Egyptians to the Maya, these were not just buildings, they were precise geometric expressions of a cosmic order. Their layouts were dictated by sacred numbers, by the precise movements of the sun and stars, and by mathematical relationships like the golden ratio, a proportion of perfect balance that appears again and again in nature. The pyramids themselves are not just piles of rock, they are mountains of applied mathematics, their angles and dimensions echoing celestial cycles. This was architecture as a form of prayer, a way to build harmony between the human world and the universe. But how do you transfer such a complex celestial design onto a rugged, uneven landscape? The tools were deceptively simple. Long sighting poles were placed in the ground to create alignment over vast distances. Water levels, using the unerring nature of liquid to find a true horizontal plane, ensured that every layer started perfectly flat. With these basic instruments, they could project their intricate plans from a small drawing onto a monumental scale with breathtaking accuracy. This reveals a powerful intellectual framework. Every single cut, the placement of every multi-ton block, was guided by this overarching geometric vision. The stonemason shaping a jigsaw piece for a wall was not just making it fit its immediate neighbors. He was contributing a single piece to a vast, three-dimensional puzzle that had been perfectly mapped out in advance. This level of planning forces us to ask an even more compelling question. What kind of tools could possibly execute such perfect cuts, creating those seamless, paper-thin joints that have mystified us for centuries? The tools themselves seem almost too simple to be true. Stone hammers, rounded dolerite pounders, and soft copper saws have been found scattered near ancient quarries. How could such basic items shape solid granite? The answer lies not in the complexity of the tools, but in a deep, intuitive mastery of physics. These builders understood forces we still use today. They knew that wood expands with tremendous power, so they would drill a line of holes into a granite seam, hammer in dry wooden wedges, and then slowly pour water over them. As the wood swelled, it created an immense, controlled pressure that cracked the stone along a perfectly straight line, as clean as any modern cut. For the intricate work of sawing and drilling, they turned to one of the hardest substances on Earth, sand. By using a simple copper blade and adding a slurry of wet quartz sand, they created a powerful abrasive saw. The copper was soft, yes, but it was just hard enough to press the sharp quartz crystals into the granite, grinding through it with patient, persistent friction. It was a slow, deliberate process, a conversation between the worker and the stone. Modern experiments have proven its effectiveness. A dedicated team using these exact methods can, over time, shape a granite block with a level of precision that seems to defy their rudimentary toolkit. This completely upends our modern assumption that advanced results require complex machinery. It highlights a different kind of advancement, one built on profound knowledge of material behavior and the clever application of mechanical advantage. With these simple yet brilliant methods, they could shape the stone, but this only leads to the next, even greater logistical puzzle. How did they move these perfectly shaped, multi-ton blocks across miles of rugged terrain and lift them into perfect position? The quarry was not just a source of stone, it was a training ground for the mind. Before a single block could be moved, it had to be born from the living bedrock, and this required a deep, almost psychic connection to the material. Workers would first study the granite face for hours, searching for its hidden language, the natural fracture lines and grain that ran through it like a secret map. Then they would apply a principle of controlled violence. They did not simply attack the stone, they guided its own internal stresses to do the work for them. One of the most effective methods was thermal shock. A fire would be built directly against the rock face, heating it intensely. Then, just at the right moment, workers would douse the hot stone with water. The rapid, uneven cooling created tremendous internal strain, and the granite would split with a loud crack, shearing off along a clean, natural plane. This was not brute force. It was a precise application of physics, using heat and water like a key to unlock a massive block from the earth. Once freed, the real artistry began. With rounded hammerstones and pounding balls of even harder rock, workers would begin to peck away at the block, a process that was deafening, dusty, and incredibly slow. Each strike was a calculation, removing tiny chips to slowly reveal the form hidden within. This was not random chipping, it was a subtractive sculpture on a colossal scale. The craftsman had to hold the vision of the final, perfectly fitted ashlar in his mind while he worked the raw, irregular mass in front of him. He was guided by years of apprenticeship, learning to see the geometry inside the stone. This rough shaping at the quarry was a critical logistical step. By removing excess material at the source, they dramatically reduced the block's weight, making the unimaginable task of transport just slightly more possible. The precision we marvel at in the finished walls began right here, in the dust and noise of the quarry. It proves that the lost principles were not just about final assembly, but a holistic system that governed every single step, from the moment the stone was awakened in the earth to its final, silent rest in a monument meant to last for eternity. An 800-ton stone does not move by force alone, it moves by cleverness. Visualize the workers at a place like Baalbek, facing a block of limestone heavier than a fully loaded jumbo jet. Their solution was a masterclass in physics. They would have prepared a pathway not with pavement but with a carefully laid track of wooden rails. A massive sledge carried the stone, and the true secret was poured out before it, a slick slurry of wet clay and water. This mixture acted as a perfect lubricant, dramatically reducing the friction that would have otherwise made the task impossible. Teams of laborers pulling on great ropes could then set the colossal weight in motion with a surprising efficiency. This image of mass manpower is compelling, but it is only part of the story. For navigating sharp turns or uneven ground, evidence points to an even more ingenious idea: the use of counterweights and pivots. Imagine a massive stone acting as a fixed anchor, with ropes run through a system that allows the larger block to be carefully pivoted or even lifted a small amount, redistributing its weight to overcome an obstacle. The ancient Egyptians demonstrated a similar brilliance on the water. To transport their towering obelisks, they likely waited for the annual flood of the Nile. The rising waters would have allowed them to float specially constructed barges right up to the quarry site. The giant stone would be carefully maneuvered onto the vessel, and the river itself would then carry the immense load for miles, turning a seemingly impossible land journey into a graceful, floating procession. At the heart of every one of these methods was a profound, intuitive grasp of two fundamental principles: the management of friction and the intelligent distribution of weight. They were not just dragging rocks, they were orchestrating a delicate dance between mass and movement. This successful transport was a logistical miracle, a symphony of coordinated effort and applied physics. Yet it presents the final and perhaps most breathtaking puzzle of all. Once this mountain of stone arrived at the sacred site, how did they lift it into the air and set it into place with such hair-raising precision? The final placement of each stone was a moment of truth, a meticulous dance of precision that transformed a collection of individual blocks into a single, unshakable entity. This principle is best understood not by looking at a single stone, but by observing the entire wall. Stand before the iconic walls of Machu Picchu, and you are not looking at a simple stack of rocks. You are witnessing a three-dimensional jigsaw puzzle of breathtaking complexity. Stones of every conceivable size and shape fit together without a single drop of mortar, their edges flowing into one another in a seamless tapestry of stone. This technique, known as Ashlar Masonry, was far more than an aesthetic choice. It was a brilliant engineering solution born from a deep understanding of geometry and physics. Each stone was painstakingly carved into a unique, irregular polygon. Why this complex shape? Because these interlocking forms act like gears, distributing any structural stress evenly across the entire wall. When an earthquake strikes, a rigid wall built with mortar is brittle and will crack, but a wall like this is flexible. It can sway, shift, and settle without collapsing, as the energy of the tremor is dissipated through the countless interlocking joints. The stones literally hold each other in place. The method used to achieve this perfection was a lesson in patience and spatial genius. It was an iterative process of fitting. A stonemason would first roughly shape a block. Then came the test, carefully lowering it into the gap, waiting for it in the wall. He would then examine the contact points, looking for the faintest shadows of gaps. The block would be lifted out, and with a few precise taps of his hammerstone, he would remove just a tiny bit more material from the high spots. He would then test it again and again and again, in a slow, deliberate cycle of refinement until the fit was so flawless that the seam between the stones virtually disappeared. This was not a process that valued speed. It valued perfection. It required the craftsman to hold a complex three-dimensional map in his mind, understanding how the unique shape of his block would interact with the unique shapes of all its neighbors. The resulting walls are more than just structures. They are a testament to a powerful principle that true strength can come from perfect geometry, not just from mass or adhesive. The wall itself becomes the binding force. This mastery of static forces, of making structures that could dance with the earth, leads us to wonder about a final, even more elusive element of their craft. How did they ensure that every angle, every alignment was not just strong but cosmically perfect, locked into the movements of the heavens themselves? The rhythmic, scraping sound of stone on stone was the secret symphony of perfection. For hours, perhaps days, workers would patiently rub two granite surfaces together, a thick slurry of wet sand and water trapped between them. This was not a haphazard sanding. It was a precise, iterative dance of abrasion. The harder stone would slowly grind the softer one, each movement transferring the microscopic high points from one surface to the low points of the other. Over time, this created two faces that were not just flat, but perfectly complementary, locking together with an intimacy that defied their massive weight. The goal was not always 100% contact across the entire face. Often, the craftsmen employed a brilliant labor-saving strategy. They would leave carefully planned raised bumps, known as bosses, on the central areas of the stone. These bosses became the primary load-bearing points, ensuring the block's immense weight was transferred securely to the one below it, while the surrounding areas were slightly recessed. This meant they only had to achieve a flawless, polished fit on a few critical square inches, rather than the entire multi-square foot surface, saving an incalculable amount of time and effort without sacrificing any structural integrity. The final act was a progression of refinement. Starting with coarse, sharp quartz sand, they would gradually move to finer and finer grits, perhaps even using river silt for the last polish. This patient, step-by-step process could produce a surface so impossibly smooth that the seam between two blocks would become visually invisible, creating the illusion that the stones had been fused together by some unknown force. This technique reveals a foundational principle of their entire approach. They did not seek to make one perfect, heroic cut. Perfection was instead a cumulative achievement, built through persistent, low-tech refinement. It was a testament to the power of patience over power, of gradual, intelligent effort over a single, dramatic act of force. A small clay model, no larger than your hand, could hold the entire geometric soul of a temple. These miniature guides, meticulously shaped by master architects, were more than just reference objects. They were the physical embodiment of a grand design. For the stonemason who would never see the full architectural plan, this model was his entire world. He could turn it over in his palms, tracing the precise angles and intersections with his fingers, internalizing the complex three-dimensional relationships his single block of stone needed to fulfill. This system of tangible communication was the invisible thread that tied hundreds of workers together. While one team quarried stones in a distant valley, another was shaping foundation blocks at the building site, and both were guided by the same unified vision, scaled down to fit in a workshop. This reliance on physical models and templates reveals a startlingly modern approach to project management. It allowed for decentralized, simultaneous work on a massive scale without the chaos you might expect. Every craftsman was an artist interpreting a shared score, ensuring his individual contribution harmonized perfectly with the whole. The evidence for this guiding principle is etched into the stones themselves. On the Giza Plateau, archaeologists have found faint incised lines and carefully marked guide points on the bedrock, the ghostly footprints of the pyramid's original layout. These were the full-scale templates, the real-world translation of the master plan. Workers used these permanent marks to constantly check their progress, using simple tools like plumb bobs and straight edges to ensure every course of stone was perfectly level and every corner remained true. This was a system built on redundancy and verification. The small model provided the vision, the string layouts established the alignments over distance, and the incised lines on the stone provided the daily, hands-on reference. It was this layered system of guidance that transformed a mountain of disjointed rock into a singular geometric monument. The true sophistication here lies not in any one tool, but in the seamless flow of information from the architect's mind, through the model, and directly into the mason's hands, a communication system so effective it built wonders that have endured for thousands of years. The final polished stone was more than a building block. It was a point of contact with the heavens. For the master builders, the true north was not a vague direction on a compass. It was a celestial anchor point, a fixed star in the eternal turning of the sky. To align a pyramid's base with this cosmic axis required more than simple observation. It was an act of high-precision astronomy. Imagine the architects of the Great Pyramid, not as laborers, but as astronomers, patiently tracking the slow circling of a single star around the pole. By marking the points on the horizon where it rose and set, they could bisect the angle to find a true north alignment so accurate it deviates by less than a fraction of a single degree. This was not a lucky guess. It was a calculated scientific achievement. This celestial connection infused every aspect of the work. A temple gateway might be designed so the rising sun on the summer solstice would flood the inner sanctum with light, transforming the stone corridor into a momentary conduit of solar power. The entire structure became a colossal calendar and a cosmic clock, its geometry permanently recording a profound understanding of celestial cycles. The motivation behind this painstaking precision was as much spiritual as it was scientific. When your architecture is a terrestrial map of the heavens, every millimeter of error is a flaw in that sacred connection. The drive for perfect joints and precise angles was fueled by a desire to build a bridge between the human world and the divine order. This cosmological purpose provided the incredible patience and dedication needed to shape stones for years, ensuring that the final creation was not just stable but sacred. The geometry of the earth was made to mirror the geometry of the sky. This leads us to a final, humbling thought. We have explored the how, the tools, and the techniques, but the full picture of their knowledge remains tantalizingly out of reach. What other principles, what deeper understanding of our world have been lost to the silence of the centuries? A perfectly shaped granite block rings with a clear, bell-like tone when struck, while a flawed one answers only with a dull, lifeless thud. This subtle sonic signature was a master mason's final test of quality. The ancient builders understood that sound travels through solid material with unerring honesty, revealing hidden fractures and imperfect contact points that even the most discerning eye could miss. They listened to their stonework, using the resonance as a diagnostic tool to ensure every joint was true. This was quality control that engaged the senses, where the ear verified what the hands had built. This acoustic awareness may have extended far beyond simple testing. Some researchers propose that the massive, resonant chambers inside the Great Pyramid were not just architectural spaces, but were carefully tuned for specific sonic properties. The precise angles and smooth, hard surfaces could have been designed to amplify certain frequencies or create standing waves, transforming the chamber into a powerful instrument for ritual or meditation. This suggests a worldview where architecture was not merely physical but vibrational. The stones were chosen and placed not only for their visual perfection and structural strength, but for how they conducted energy, for the way they shaped the very air within a sacred space. Modern materials science is only now beginning to fully grasp the deep connection between a material's microscopic structure and its acoustic behavior. These early civilizations, however, seemed to operate from this holistic understanding intuitively. They saw the vibrational essence of stone as inseparable from its physical form, building not just for the ages, but for a harmony that could be felt and heard. This integration of sound into their craft reveals a dimension of their genius that is both profoundly artistic and startlingly scientific. The ground itself can betray you in the Andes. A powerful earthquake can reduce a modern concrete building to rubble in moments, yet the ancient Inca walls of Cusco often remain, a serene puzzle amidst the chaos. These structures do not resist the earth's violent shaking by being rigid and unyielding. Their survival secret is the exact opposite. They are designed to move. The intricate, jigsaw-like pattern of polygonal masonry is a masterclass in passive seismic defense. Each irregularly shaped stone is locked into its neighbors, creating a dynamic, flexible whole. When the earth trembles, a wall of rectangular blocks, bound by rigid mortar, will crack and collapse as it fights the motion, but a polygonal wall behaves differently. The stones, with their countless interlocking joints, are allowed a minute amount of independent movement. They shift, they settle, they sway in a coordinated dance, absorbing the seismic energy and dissipating it harmlessly throughout the entire structure. This was not a fortunate architectural coincidence. It was a deliberate, brilliant engineering principle born from centuries of observing how the land itself behaves. These builders understood a fundamental truth that modern engineering has only more recently embraced. To survive an earthquake, a structure must be resilient, not just strong. It must be able to flex and flow with the forces acting upon it. The geometry of their walls was a direct response to their environment. a calculated application of knowledge that allowed their creations to literally dance with the earth and remain standing for another 1,000 years. This foresight reveals a level of structural intelligence that feels almost prophetic, forcing us to reconsider what we mean when we call a civilization advanced. A story persists in the high Andes, whispered from one generation to the next, about a plant whose sap could make stone soft. According to these accounts, ancient masons would apply this mysterious substance to the surface of solid granite, and for a brief time, the rock would become pliable like wet clay. They could then mold it, press it, and carve intricate designs with relative ease before it slowly returned to its original adamantine hardness. This is the seventh and most controversial principle, the lost art of softening stone. Mainstream archaeology remains deeply skeptical, for no recipe or chemical vessel has ever been found. Yet, certain features on the stones themselves keep the question alive. Look at surfaces that appear almost poured into place, or at deep, continuous spiral grooves in hard rock that would be incredibly difficult to produce with simple abrasives. How were these achieved? Some modern experiments have shown that certain organic acids derived from local plants can, in fact, significantly weaken the surface bonds of silicate rocks, making them easier to work. The effect is not magical liquefaction, but a dramatic reduction in grinding resistance. This would not replace the need for skill, but it could exponentially speed up the most laborious stages of shaping. Whether this was a widespread technique or a localized secret, the very idea forces a profound shift in perspective. It suggests that their knowledge extended beyond physics and geometry into a sophisticated understanding of chemistry. They may have seen the world not as a collection of separate elements, but as an interconnected system where a plant could hold the key to commanding stone. This challenges the very timeline of technological progress, hinting at a branch of material science that was discovered, perfected, and then ultimately lost to time, leaving behind only legends and stones with shapes we still cannot fully explain. Scattered across the river deltas of Costa Rica lie objects that defy simple explanation, the perfectly round stone spheres of Diquís, carved from resilient gabbro. These orbs range from the size of a melon to colossal spheres over 2 meters across, weighing several tons. Their surfaces are unnervingly smooth, their curves so flawless that measurements often reveal a variation in diameter of less than a single centimeter. This is not the work of random nature. It is the signature of a culture that pursued geometric perfection as an end in itself. The creation process was a symphony of patience and technique. Craftsmen likely began by selecting a suitable boulder and using fire and water to initiate controlled fractures, spalling off large, unwanted pieces. Then came the endless pecking, using a harder stone to strike the surface thousands upon thousands of times, gradually knocking away material to reveal the rough form of a sphere hidden within. The final, breathtaking precision was achieved through grinding. Using sand and water as an abrasive, they would have painstakingly polished the stone, perhaps even rotating it against a fixed abrasive surface or using a reciprocal grinding motion for untold hours until no imperfection remained. How did they maintain such perfect symmetry without modern measuring tools? The most plausible answer lies in a simple yet brilliant application of geometry. They likely used a cord fixed at a central pivot point, sweeping it around the stone to constantly check for any deviations in the radius. Any high spot that caused the string to go taut would be carefully ground down in a slow, iterative dance that transformed a rock into a perfect embodiment of the sphere. The profound mystery is not really how they were made, but why. These spheres were often arranged in elaborate patterns, lines, and triangles, their placement seeming to hold a meaning we can no longer decipher. They were objects of pure form, demonstrating that precision was not solely for structural integrity, but for a deeper, more abstract purpose, perhaps mapping the heavens or representing cosmic bodies in a long-forgotten worldview. They stand as a silent, powerful reminder that the drive for perfection can be as much about beauty and symbol as it is about strength and function. A single drop of water holds the secret to a perfectly level horizon. While the ancients lacked laser levels and digital instruments, they possessed a tool more reliable than any machine: the unerring nature of water itself. To lay the foundation for a massive temple platform, Roman engineers would dig a network of shallow trenches across the entire building site and fill them with water. The surface of this makeshift canal system would naturally settle into a perfectly level plain, regardless of the hills and valleys of the landscape beneath it. By measuring down from this liquid datum line at countless points, workers could mark the exact height for the foundational bedrock, ensuring the entire sprawling structure began its life perfectly flat. This was not a guess, it was geometry written in liquid, a principle so fundamental it remains the basis for leveling to this day. But how did they transfer this ground-level perfection to the rising walls high above? The solution was as elegant as it was simple. They used long, flexible tubes made from animal bladders or hollowed-out reeds filled with water. Since water always seeks its own level, the surface at one end of the tube would be exactly as high as the surface at the other end, even if that other end was held 50 feet in the air. A worker at the top of a growing wall could hold his end of the tube, while a partner on the ground kept the reference end in the main water trench. By sighting across the two water levels, they could mark a perfectly horizontal line on the new stone course, guaranteeing that every layer built upon the last was just as true as the foundation itself. This hydraulic genius extended to vertical alignment as well. A deep, still reflecting pool could act as a giant plumb bob. By observing the reflection of a towering obelisk or a wall in the calm water, builders could check for any lean or deviation from perfect verticality. Any tilt would be immediately apparent in the mirrored image, allowing for corrections long before the structure became unstable. This profound trust in a natural element reveals a cornerstone of their entire philosophy. They did not seek to conquer nature with complex tools, but to collaborate with it, using the immutable laws of physics as their most trusted assistant. The stability of their greatest monuments, standing for millennia, began with the quiet, unwavering truth found in a pool of water. A master stonemason's knowledge lived in his hands. For a young apprentice, the first years were not about reading plans or memorizing formulas, but about silence and observation. He would watch how his teacher listened to the sound of a hammer strike, learning to distinguish the clear ring of good stone from the dull thud of a hidden flaw. He would spend days mixing just the right consistency of sand and water for polishing, learning the recipe not from a page, but from the feel of the slurry between his fingers. The intricate principles of geometry and physics were encoded into the very rhythms of the work, passed down through chants, stories, and the silent language of demonstration. This was a knowledge system built on intimacy. An apprentice did not just learn what to do, he absorbed how it felt to do it correctly, developing a somatic memory, a physical intuition that no written manual could ever capture. The precise angle for a perfect joint was not a number he calculated, but a posture his body remembered after guiding a saw along a chalk line 1,000 times. This long and rigorous apprenticeship was the living library that preserved these sophisticated techniques across generations. It ensured that the master's deep understanding of stone behavior, his tricks for managing friction, and his eye for a perfect fit were transferred not as abstract concepts but as a living craft. This continuous chain of mentorship was the true backbone of their architectural genius. Its fragility, however, is what ultimately created the great silence we confront today. When a civilization experienced profound social collapse, or when conquest shattered its cultural institutions, this delicate thread was severed. The masters were gone before they could pass on their deepest secrets, and the apprentices who held fragments of the knowledge could no longer piece the entire system back together. The principles faded because they were not just intellectual, they were cultural and embodied. You cannot rediscover the feel of a perfect cut by studying a finished wall, any more than you can learn to dance by examining footprints. This loss forces us to ask a poignant question about our own world. What profound understandings, what subtle arts of living and building might we be losing in our own relentless march toward progress, simply because we stopped sitting at the feet of the masters and listening to the quiet wisdom held in their hands? The sun itself could become a master mason's finest tool. Visualize a team preparing to set a massive granite lintel into its final, precise position atop two upright monoliths. The fit needs to be impossibly tight, a task that seems to demand superhuman strength or impossible leverage. Their solution was not to fight the stone's immense weight, but to use its own physical nature against it. They might have carefully shaded one of the upright support stones, perhaps by draping it with wet cloths, keeping it cool and contracted. Meanwhile, the lintel block destined to rest upon it was left fully exposed to the blazing sun, its surface growing hot to the touch. As the granite absorbed the heat, it expanded, its dimensions growing by a tiny but critical few millimeters. In this temporarily expanded state, the workers could maneuver the heated block into place with a small but manageable gap. Then they waited. As night fell, the heated stone slowly cooled and contracted, while the shaded stone perhaps warmed to the ambient temperature. This thermal dance pulled the two surfaces together, closing the final gap with a gentle, relentless pressure that no team of laborers could ever achieve. The resulting fit would be a product of the stone's own natural behavior, locked into a perfect, permanent embrace. This technique would demand a profound, almost intuitive grasp of material science. The builders needed to understand that different types of stone expand at different rates, a property known as the coefficient of expansion. Using this method on two mismatched rocks could cause a fit to fail, or worse, create enough stress to crack the stone. The very possibility that they employed such a method speaks to a level of environmental intelligence we are only now fully appreciating. They were not just building with the landscape, they were building through it, using the daily cycle of the sun as an integral part of their construction machinery. This turns the entire environment from a challenging backdrop into an active participant in the creative process. It suggests that the greatest secret of these builders may not have been a single lost tool, but a lost way of seeing the world itself as a collection of dynamic, interconnected forces waiting to be harnessed. The massive stone heads of Easter Island seem to stare inward from their remote Pacific home, while the needle-sharp obelisks of ancient Egypt reach for the sky. These two civilizations could not have been more separated by geography and culture, yet they were united by a common, colossal ambition. Both chose to express their beliefs and power through the most permanent medium they knew, stone, and both confronted the same staggering physical challenges. They had to extract, shape, and move monoliths of a scale that still defies belief. The Rapa Nui people carved their iconic moai from the soft volcanic tuff of the Rono Raraku quarry, using simple hand picks made of harder basalt stone. Each statue was a massive, singular project, shaped entirely in the quarry before its arduous journey across the island. In distant Aswan, Egyptian artisans faced a different kind of rock, the unyielding red granite. Their tools were heavy dolerite pounders, and their work was a symphony of organized labor, shaping one of the most difficult stones on Earth into sleek, towering obelisks for the pharaohs. The solutions they developed for transport reveal a fascinating divergence dictated by their unique environments. On Easter Island, evidence suggests the moai were moved in a standing position, rocked and walked forward in a slow, careful procession that turned the statue itself into a walking giant. In Egypt, the practical solution was horizontal. Giant obelisks were carefully lowered onto massive wooden sledges and dragged along prepared causeways, their immense weight distributed across a wide surface. This stark contrast in method is the entire point. There was no one secret manual, no single lost principle that every culture shared. Instead, there was a universal human drive to create something that would outlast generations, and a profound, localized intelligence that devised unique solutions. The true wonder is not a hidden global technology, but the incredible adaptability of the human mind when faced with a shared, monumental problem. The Rapa Nui adapted to their island's resources and rolling hills, while the Egyptians mastered the logistics of the Nile. Both found a way to make the impossible happen, proving that the greatest principle of all was the ability to listen to the land itself and answer with ingenuity. A single, perfectly carved line was a prayer made solid. For the ancient master mason, his work was a form of meditation, a physical act of translating cosmic harmony into stone. His chisel was not just shaping rock, it was tracing the invisible patterns of the universe, making the divine order visible and tangible for all to see. This was the sacred dimension of their craft, where belief was the ultimate engine of precision. A perfect circle was not merely a pleasing shape, it represented the eternal, cyclical nature of time and the heavens. A square was the stable, four-cornered world of the earth. When these forms were integrated into a single structure, the building itself became a map of existence, a bridge connecting the human realm with the celestial one. This symbolic imperative provided a motivation far beyond mere utility. A structural flaw was a crack in the universe they were building. A misaligned angle was not just a technical error, it was a spiritual transgression, a failure to correctly mirror the perfection of the gods. This profound responsibility demanded an unparalleled level of care and dedication. It explains why a team of workers would spend years polishing a single block of granite to a mirror finish, or why an architect would obsess over an alignment accurate to a fraction of a degree. The drive was not for efficiency but for holiness. This deep intertwining of faith and engineering may have been the ultimate catalyst for their refinement of technique. The desire to build a worthy home for the divine pushed them to observe the stars with greater accuracy, to understand material science more deeply, and to develop geometry as a sacred language. Their greatest constructions were, in essence, three-dimensional prayers, their silent stones speaking a language of perfect form that was meant to last for eternity. This spiritual foundation forces us to reconsider the very nature of their achievement, seeing it not as a collection of clever tricks, but as the physical legacy of a world, where the material and the spiritual were seamlessly, beautifully one. A modern stonemason, equipped with diamond-tipped saws and laser levels, once attempted to replicate a section of an Inca wall. He selected his granite, carefully cut his blocks, and assembled them with painstaking care. Yet when his work was placed beside the ancient original, the difference was undeniable. His joints, though precise by modern standards, were visibly thicker. The seamless, organic flow of the ancient stones was something his advanced tools could not capture. This is the quiet frustration that confronts modern archaeology. We possess machinery of unimaginable power, but we have lost the nuanced art of the hand. The existence of these impossible structures forces a profound re-evaluation. It challenges the comforting, linear story of human progress, the idea that we are always building, always improving. Instead, it suggests a different rhythm to history, where specialized knowledge can rise to an incredible peak, only to be forgotten, leaving behind only the silent, majestic evidence of its existence. To understand what was lost, researchers now turn to technology of a different kind. Using high-resolution 3D scanning and sophisticated structural analysis software, they can reverse engineer these ancient techniques. The scans reveal subtleties invisible to the naked eye, micro-variations in the stone surfaces that acted as clever locking mechanisms, or patterns of wear that suggest exactly how the stones were ground together. This digital archaeology is not just an attempt to solve a historical puzzle. It is a conversation with the past that is actively inspiring our future. The principles of flexible, mortar-less construction, so perfectly mastered by the Inca, are now being studied for modern earthquake-resistant architecture. The ancient understanding of how to use local materials with minimal environmental impact offers powerful lessons in sustainable building. The very stones that have stood for millennia are proving to be a living library, holding secrets about resilience and harmony with the natural world that we are only now learning to read again. A broken hammerstone was never just discarded. In the dust of a working quarry, a spent tool could become a wedge, a polishing pebble, or packing material for the transport sledges. This was a world without waste, where every fragment of stone held potential value. The breathtaking precision we see in the final monuments was born as much from this pragmatic necessity as from any spiritual ideal. Consider the immense investment required to free a single 100-ton block from the earth and drag it for miles. Every swing of the hammer, every day of labor was a cost. A major cutting error could mean weeks of lost work, or worse, the complete loss of a precious, irreplaceable resource. This harsh reality forged a culture of getting it right the first time. Methods were refined not just for beauty but for survival, developing a workflow that minimized risk and maximized the yield from every piece of stone. We see this practical genius in the evidence of reclamation. A block that fractured during shaping was not abandoned. It would be carefully reassessed, its dimensions remeasured, and then reworked into a smaller building block, perhaps for an interior wall where its imperfections would be hidden. A massive lintel that cracked during transport might be deliberately split into several smaller slabs for paving. This was not a sign of failure, but of profound adaptability. It reveals a mindset that saw the inherent potential in every material, no matter its condition. The drive for perfect joints was in part a direct result of this resource economy. A perfectly fitted block required no mortar, a material that would have required its own separate and laborious production process. By achieving such tight seams, they eliminated the need for an entire category of secondary materials, streamlining the entire construction chain. This principle of efficiency forces us to see these builders not only as brilliant geometers and astronomers, but as masterful project managers. They understood the entire life cycle of their materials, from quarry to final placement, and their methods were designed to honor the immense effort embedded in every single stone. Their legacy is not just in the monuments that survived, but in the quiet intelligence of having left almost nothing behind. The idea that lasers from beyond the stars built the pyramids makes for thrilling fiction, but it does a deep disservice to the genius of our own species. This narrative, while captivating, often arises from a place of modern arrogance, an assumption that our ancestors with their simple tools were incapable of such grandeur. The truth, however, is far more inspiring. Every mark on the stones, every precise angle, points not to alien intervention, but to human hands guided by generations of observation and innovation. The so-called mystery is not a void to be filled with science fiction, but a puzzle waiting to be solved by archaeology and a renewed respect for ancient intellect. Consider the logic for a moment. If an advanced extraterrestrial race possessed technology capable of moving 1,000-ton blocks with ease, why would they choose the most labor-intensive methods imaginable? Why use stone hammers and abrasive sand? Why leave behind quarries filled with the evidence of trial and error, of broken tools and abandoned blocks? The archaeological record is not a clean, sterile landing pad for alien machinery. It is a messy human workshop filled with the fingerprints of countless artisans who learned, through painstaking effort, how to collaborate with their world. The real marvel is that they achieved the impossible with what they had. They did not have steel, but they understood the physics of levers and pivots. They did not have silicon chips, but they mastered celestial mechanics with knotted strings and sighting poles. They turned the sun into a precision tool and used the unerring surface of water as their level. To attribute their work to a lost super-civilization is to ignore the steady, cumulative nature of technological development. Knowledge was not given to them, it was earned, passed from master to apprentice over centuries, refined with each new project until it reached a breathtaking peak. This shift in perspective is crucial. It moves the conversation from a search for outside saviors to a celebration of human potential. It asks us to look at these monuments not as alien artifacts, but as libraries of forgotten knowledge, each stone a page in a manual of applied physics and environmental wisdom. The greatest secret they hold is not about who helped them, but about what human beings are truly capable of when driven by a unifying purpose, a deep cultural tradition, and a profound connection to the materials and forces of their world. The mystery is not a sign of our ancestors' ignorance, but a challenge to our own. Machu Picchu does not crown its mountain, it converses with it. The citadel's terraces and temples follow the ridge's natural contours so perfectly that from a distance, the built and the born environments merge into a single, breathtaking form. This was architecture not as an imposition, but as an extension of the land itself. The builders did not flatten the summit to suit their design. Instead, they allowed the mountain's own rugged geometry to dictate the layout of their sacred city. Stones were not merely placed upon the bedrock, they were keyed into it, with foundations carved to interlock with the living rock below, creating a bond so profound that the entire structure became one with the mountain. This deep integration reveals a principle far more sophisticated than simple construction. It was a philosophy of harmony. The shapes of the surrounding peaks were often echoed in the roof lines and wall angles, a visual poetry that tied the human creation to its celestial backdrop. This required a profound flexibility in their application of geometry. Their precision was not a rigid mathematical straitjacket. It was a fluid language they could speak in harmony with the Earth's own irregular rhythms. A perfect square might be subtly adjusted, its corners softened to accommodate an ancient, unyielding stone outcrop. A planned wall might curve gently to follow a natural watercourse. This adaptive genius meant that no two solutions were ever exactly the same, yet every one achieved the same goal: a seamless union between the work of human hands and the work of geological time. The result is a feeling of timeless stability, as if these structures were always meant to be here, grown from the soil rather than built upon it. How does our modern approach to building, so often focused on dominating a landscape, compare to this ancient art of collaboration? Their legacy suggests that true endurance may come not from fighting nature, but from learning to listen to its deep, geometric voice. The future of these mysteries is being forged in a cloud of stone dust. Inside a modern workshop, an experimental archaeologist raises a heavy dolerite hammer and brings it down on a block of granite. The sound is a sharp, deafening crack, a direct echo from the past. This is not a theoretical exercise, it is a physical conversation with history. Each strike, each hour spent grinding with sand and water, is a question posed to the ancient masters. Failure here is as valuable as success, for every technique that does not work eliminates a possibility, narrowing the path toward the truth. This hands-on research is now supercharged by digital eyes. Using photogrammetry, scientists can capture thousands of overlapping photographs of a single stone joint, stitching them together into a three-dimensional model of astonishing accuracy. On a computer screen, we can now zoom into the surface of a 500-year-old Inca stone, examining the microscopic striations and tool marks that are invisible to the naked eye. We can trace the exact path of the artisan's final polishing stroke, understanding the precise motion he used to achieve that impossible fit. Beyond simple visualization, we can subject these digital twins to forces they were built to withstand. Finite element analysis software allows engineers to simulate earthquakes, wind loads, and settling over centuries, watching how the unique polygonal geometry of an ancient wall distributes and dissipates stress. These simulations reveal the hidden logic behind the shapes, showing us that what looks like artistic choice was often a brilliant calculation for survival. This global, collaborative effort, blending the raw physicality of the hammerstone with the silent power of the algorithm, is slowly piecing together a fragmented manual of lost knowledge. We are not just rebuilding walls, we are rebuilding a mindset, learning to see stone through the eyes of those who mastered it without ever conquering it. Our journey from the raw quarry to the silent, soaring monument reveals not one single secret, but an entire tapestry of interwoven principles. We have witnessed the deep material knowledge, the celestial geometry, the physics of friction and movement, and the spiritual drive that infused every action. These were not the crude efforts of a primitive people, but the highly refined arts of a sophisticated intelligence, born from generations of patient observation and a cultural imperative for perfection. The true lesson etched into these stones is about a fundamentally different way of seeing our world. It was a holistic vision where science and spirit were one, where knowledge was not separated from the environment but deeply integrated with it. The granite and limestone themselves stand as the ultimate, unshakable testimony to human ingenuity. If this exploration has reshaped how you see the pillars of the past, we would love to hear your thoughts in the comments below. Subscribe to join us as we continue unraveling the greatest mysteries our history has left behind.